Welcome back, geometers. It's time for algebra class. Cool. Like, legitimately, we're doing a bunch of algebra in here today to make sense of geometry in a different lens. So, for today, your guys' feedback is going to be super duper important, and it realistically, it is always super duper important. But in 2.4, the last section of our chapter, just throwing that out there, 2.4, the last section of chapter 2. We are going to be looking at the slopes, and I'll write a regular S, slope, or slopes, of, I would use a shorthand if I were you, but we're going to talk about parallel and perpendicular, which somebody remind me the shorthand for perpendicular?
The T, upside down T.
Upside down capital T. The slopes of parallel and perpendicular lines. All right, Andrew, big question. Is it Blockman that's happening on that calculator right now? Okay, you got me good. If you're working on the homework, I appreciate that, but I want you to switch gears. Let's come here because getting in a late homework does not benefit the next section.
Yeah, I was just wondering how you got one of the answers, because I get them a little goofed up.
Oh, it'd be so awesome for you to ask that when we're going over it. But I appreciate and I respect you trying to figure it out there. If there's more questions, we'll have time, I think. Okay, so right off the bat, I'm kind of going to work under the assumption that nobody in here remembers anything about algebra. I don't think that's really true, but it's just easier if we start there and then build up and speed up as needed. Our very first focus today, when we talk about slopes of parallel and perpendicular lines, is if we're going to talk about slopes of stuff, we better make sure that we all agree on what slope is. And remind me real quick, what's the kind of standard that we use in American math for slope?
Angle?
Not angle. Y equals something x plus b. What's this something?
Y equals E.
M. M is the standard that we use for slope. I have no idea why. My guess is there's a Latin or a French word that probably means slope and starts with that letter, but I could be wrong. Okay, when we talk about slope, without being crazy wordy, I'm going to say the wordy version. We're just going to look at the mathy version. The slope, in general, all it is a ratio of how quickly a function or a line, whatever it is, rises over run. The ratio of rise to run. A ratio is just a fancy word for a fraction. Now, when we do it in here, we're going to write this, and it's really just a recall, but we have a few different versions of it, and we're going to go through like your whole math education here in about the next 30 seconds with slope stuff. When you're first introduced to slope, you likely see it is defined as rise over run. This is like 6th or 7th grade when you first start talking about lines, I think. From here, you might have learned a fancy Greek letter, delta, y over delta x. Does that one also look familiar? Okay, when you see the Greek letter delta, and this is a capital delta, but this Greek letter delta, it shows up in math all over the place. It also shows up in science. What does delta represent when we see it written?
Triangle.
So it is a triangle, but that's not what it represents. I'm going to put this one here. Delta, that triangle, all that this is it means a change in some value. So I'm not going to write this one, but if I wanted to, it'd be a change in what over a change in what?
Change in y.
Good. A change in y over a change in x. Now, more commonly, and all of this I'm sure looks familiar to you guys, can anybody tell me how do we find delta y? How do you find a change in y? Like if I, and don't draw this one, I'm just going to think about it. Let's say I had 2 points here, and I had, I don't know, x1, y1. It's that point. And then I had another point up here that's x2, y2. So just 2 different order pairs. How would you figure out this vertical change right here? You would subtract, right? And in this picture, it'd be y2 minus y1, I assume. So if we commit to this, y2 minus y1. Really, really important. I'm going to let you guys wait until I see everybody's done writing, because I'm going to make a really repetitive statement. The order for the first numerator here, y2 minus y1, you can pick whatever you want. Doesn't matter. We just did y2 minus y1, right? The denominator must match, which means if these are my difference in the x's, or sorry, the y's, I now need the difference in the x's. What order should it show up in? x2 minus x1. It must be the same. I don't care what the first one that you write in the numerator is, but they have to match. with that in mind. It would be weird to do for this one, but somebody could have just as equally have given me y1 minus y2. That's okay. That's allowed. Now this one would be wonky because you would get a negative number. That's perfectly fine. The second I make the change in the numerator here, what must go in the denominator? x1 minus x2. Andrew, I want to stress again, I would be doing this stuff, especially if your algebra skills are maybe a little shaky. Okay, this is slope. This is how we find slope. Now, the only thing that I didn't specify here is where do all these x's and y's come from? I'm just going to add a little bit more. All of these are the same thing. Where we have 2 points either given to us or on a line, it doesn't matter. I'm going to call it given. And we'll just say that they are given as exactly what I wrote over here. x1, comma, y1, and x2, comma, y2. We get two ordered pairs. If we need to write x1, x2, and y1, y2 over parts of pairs, I'm good with it. It can help us keep stuff straight. These are points that are on a line. That's the most important part. Okay, so from here, let's knock out a couple little things. We're going to do two really quick examples, and we'll do A and B, and I just want to know what is the slope through, and let's pick a couple points. I'm going to say dot, 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 and we'll do 2 different points. All right. When I ask this next question, just so you know, I'm aware that nobody really has a favorite, but I'm about to ask, I'll show right now. Raylene, what's your favorite ordered pair on the whole coordinate plane other than 0, 0? What's that? You give me any 2 numbers is really all I'm asking for. You obviously don't have a favorite point. Maybe you do. I don't know. But give me any point. So Raylene claimed 3, 6. Okay, so I want to find the slope between 3, 6 and, Andrew, give me another point. Any other ordered pair on the coordinate plane? 8, 2. All right. Now, if you struggle with the algebra stuff, my hope is that this algebra is okay, but if it's not, that happens. If you need to write a little bit extra, any extra, here's what I recommend. Every ordered pair is always xy, right? So if we try to relate the same idea that we had here, do you agree that this is x1? And then this 6 would be a what? A y1. Over here in blue, what is this 8 value? x2. And the 2 right here then is y2. It is never required, but if you really like to have a very specific template to follow through a problem, you won't always have it because that's not really what math is, but it's nice here. Okay, I want you guys, we're going to check, find me the slope between those 2 points. I'm going to give you just a moment. Talk it out, try something. Your work should probably say m equals, and then you'll calculate your slope. I'm going to give you a head start. If you have no idea what to do, ask. Don't sit there and do nothing. Obviously, the answer will be here in a minute. Ask. Looking at this, help me out. Do you want to do y2 minus y1 or y1 minus y2, Andrew? There's no best option. Would you rather do 6 minus 2 or 2 minus 8? Or sorry, 6 minus 2 or 2 minus 6?
6 minus 2.
Okay. I'm going to try to do the colors, but I will not do this again. If I do y1, which is what we just did, minus y2, 6 minus 2. I just went this way, 6 minus 2. What has to go in the denominator here, Ray?
8x2 and x.
So careful. Notice we just did y1 minus y2 right here. What's x1?
3.
So it better be 3 minus, what's y, x2, sorry, 8. Okay, this is it. If you made a mistake, which I think a couple people might have, I don't know that I'd necessarily want you erasing, but that's okay. We'll talk about why that's the case. Raylene, did you make a mistake? And are you comfortable in answering that question?
No.
What were you erasing then? Or are you not comfortable answering?
She's not comfortable answering that either.
Yeah, I plead the, did you erase? Oh, my bad. Ashley, What did you erase?
Trying to make it perfect, but I made an extra step.
Okay.
Did y over x, which is 6 over 3, which is 2. And then I did 2 over 8, which is 1/4. But then I still did that.
Okay. So I like
I just
with
erased the first step that I made.
no, and you're okay. Oftentimes, I'll tell you guys, and I really do believe that maybe erasing isn't a great idea, and it's not because like I think it looks nicer if you don't erase and stuff. For me personally, what happens when I erase is if I make a mistake and I erase it, it's just like it's gone. It's like I never made the mistake, and I don't want to feel like I never make mistakes. I want to learn from my mistakes. It's purely a growth mindset type of thing. You do you, but Xing out and making ugly notes is always better in my opinion. Anyway, let's kick back in. What's 6 minus 2? 4 over, what's 3 minus 8? -5. Now, if you stop here, you're good. I'm not going to lie, I kind of hate it. It feels really clunky for that negative to be in the denominator here. It's not wrong. I will always take the time to go one further step. You don't have to, but it's easy to lose a negative here later in the problem. It is much more natural to either move the negative out front of everything, like this, -4/5, or, if you'd rather, -4 over 5. These three terms are all the same. I will 100% of the time avoid having a negative in the denominator.
Wait, why? How, if you get -5, how does it switch to -4?
So careful, because remember, we're looking at the whole fraction. Let's just pretend, let's use a decimal for now. This is 0.8. If I do 4 divided by -5, it's -0.8. If I do -0.8, it's -0.8 again. And if I do -4 divided by 5, it's -0.8. They're all the same fraction. Like, I know they look different, it's just where the negative goes. But in each one of these three situations, we get the same number. This is my preferred choice, with a close second and a very far behind, like, scum of the earth, number 3 choice. I'm very opinionated on where the negatives go in fractions. Okay, hypothetically, could somebody have done this backward? Now, if we say backward, you don't have to write this one. I just wanted to check it out. We did y1 minus y2. It's a good choice. Could I have done 2 minus 6 instead? Over, it matches up with 8 minus 3. Notice what happens. -4 over 5, we get the exact same answer. Can you guys tell me where I most commonly see mistakes? Like, what's your guess on where, if somebody gets this picked up, where does it most commonly happen? In the denominator, maybe. Like, kind of. I'll tell you, I see the same mistakes happen, doesn't matter if it's numerator or denominator. The most common mistake that I see is somebody will do either delta x over delta y, they'll get it upside down, which that's a big mistake. The other one is somebody will do y2 minus 3, and they'll try to do x and y and they'll mix them. Those are the most common mistakes. That one's much more common than just having it upside down. Do we need to do another pure slope problem, or can we push forward? That was like 3, that's a whole lesson in Algebra 1, that whole thing. Cool. Let's keep kicking then. Okay, so we have this idea of slope. That's all fine and dandy. As we're talking about slope, there's two main things that we're going to look at: parallel slopes and perpendicular slopes. Let's go ahead, and green feels pretty parallel to me, so we're going to introduce theorem 2.13. We won't prove it. It'll go super fast. 2.13. Theorem, I'm not even going to name it here. We're just going to write it. Two lines are parallel if and only if, which means this goes both directions, right? If two lines are parallel, then whatever we're about to write, and if whatever we're about to write, then they're parallel. Two lines are parallel if and only if their slopes are equal. And it sounds like that was more coming. We're going to have a caveat with it. Two lines are parallel if and only if their slopes are equal. That's the first statement. Now, there is one little weird situation that we encounter. Are there any lines that are hard to find the slope of, or that maybe we can't say what the slope is?
Curved line.
So curved lines, I wouldn't say is a line anymore. It's a curve. But I agree with you. That's actually the whole focus of calculus, which is kind of a cool idea. If I'm estimating, would you guys agree the slope is about 1 without a scale?
Yes.
And that's about 2 and 3. How about if it's straight vertical? I rise a bunch, right? How much do I run? If it never, like if it's just a truly vertical line.
You never run.
It doesn't run. What number is it? It doesn't. What can't we ever divide by? 0. So in the case that we get a vertical line, we can't even talk about the slope being equal to something else because our slope is undefined. My caveat, my little warning. Undefined slope, undefined, for each is also parallel. For each is also parallel. And it's a weird little just notation and definition thing. You can't say a slope equals undefined. That doesn't make sense. We just say there is no slope. And undefined slope is the same as undefined slope for this purpose. You could not really say they're equal though, okay? It's just a weird little hiccup. Okay, here's what I'm going to propose. Instead of doing just a bunch of problems like this, we're going to sneak in one more theorem real quick. And we're nearly done. For today at least. We'll see. Okay. What's today? Tuesday? So realistically, I kind of expect that we will finish 2.4 tomorrow on Wednesday. Like, I'll give you guys time to work on stuff in class today. It would look like team test then is Thursday. We'll review that on Monday, and then we'll take our test on Tuesday. Unless you guys want to push that forward. I'm cool. All right, check it out. Two lines are parallel if and only if their slopes are the same or equal. In contrast with that, we'll say two lines are perpendicular if and only if their slopes, and there's a different statement to make. Now, there was a brief minute there where my TikTok knowledge really coordinated with class. Do you guys recall what makes a slope perpendicular? So for a brief minute, do you guys all know what the woe is? Is it that? Something like that, right? Now, whether or not it really does that part, like, I don't know if it does, but it does for me. Here's my woe. It's just like that, okay? We can undo it if we want. That's fine. When you guys think about, and this is going to feel unrelated, dividing by a fraction, that's when I would use the woe, and you've probably seen me do it in class this year, I would guess. If I were to take something like this, and this is just off on the side again, 2 divided by 1/2, that sucks, right? What's better than dividing by 1/2? How do I fix this so it's not ugly? Multiply by the what? So we just literally take that 1 and the 2 and they just switch, right? Like that's where it comes from. 2 times 2 over 1 is what this would become. Now, that idea, the opposite, or the reciprocal. Everybody recognize that language. Flip the fraction, we call it the reciprocal. Now, that is almost everything. When we write this, we'll say two lines are perpendicular if and only if their slopes are, not only do they need to be reciprocals, but they need to have opposite signs. So we'll say opposite reciprocals. And then on this one, I'll do a quick little EG to demonstrate this, but we have a caveat as well. Now, caveat, that's just a fancy little consideration. It's a French word. Don't really know what it means other than, hey, one little extra comment to pay attention to. A vertical line has an undefined slope, right? If you flip something that's undefined, can you tell me what it becomes? Or let's go the other direction. Can you imagine a horizontal line? And you know what? Even if you can't, that's okay. Here's a horizontal line, that dashed line. What's the slope of that line? Everybody agrees 0? Now it could be 0 over 10, because it ran 10. It really runs however far you want. But 0 over 10, let's just say it's that. Flip it upside down, you get 10 over, and what's 10 over 0? Good catch, I was expecting 0. 10 over 0 is undefined. When we make a little caveat, if we can't check if it's an opposite reciprocal, I'm going to say undefined slope is perpendicular to a 0 slope. Now, we can't really say that it's an opposite reciprocal because you can't really tell me what's the opposite reciprocal of 0 over 10. It's not defined. It's not a number. Okay. With this, very specifically, e.g., just as a quick little example, if I have M1 that is equal to, 3/2. I know that this is perpendicular to a second slope, M2, and real quickly, help me do the woe and be real negative about it. Flip that fraction. What do you get? So the flip is just 2/3, and then that negative part, there it is. These are perpendicular to each other, right off the bat. Okay, so check it out. I want you guys to open your bell ringer real quick for me. Back to it. And I want you to determine if the line through AB and line ML are parallel or not. Your explanation is just the math that goes into it. I don't need a wordy sentence. Just show what you did to determine. Cool. Talk it out. You're going to want to have your notes, or my notes. I'll put them back up because do you guys have the points written from the bell ringer? Okay. I will keep these two theorems up. Andrew might not have it. Cool. Check it out. Find me both slopes. Let's check to see if they're parallel, perpendicular, or neither. Do this quick. And honestly, even if you just do it in your head, are you good at mathematics? Can you tell me the slope of AB?
What was that? It was 1 and 3.
So switch it, do the y's first. 7 minus 4 is 3, right?
Yeah.
Over, what's 3 minus 2?
1.
So 3 over 1, 3, right?
Yeah.
Do it for ML real quick.
And now. What am I trying to?
Just find me the slope is all then for right now.
Oh. Is it 3?
I don't think so.
Negative 3?
How are you getting that?
Negative 1, 3.
So careful. What's first, delta y or delta x?
Delta y.
Good. What's 0 minus 3? I'm looking at y2 minus y1.
Negative 3.
Okay. And 0 minus negative 1.
Positive 1.
So negative 3 over 1, that's negative 3, right? Are those exact opposite reciprocals?
Yes.
Sure. If you write it down, you're good. Like, go to that real quick. But if you write it down, I don't know that you'll agree with that. Another moment. Were we cool to chat about it? You keep working. I'm going to write it up here, and I'm going to show you the notation that I use. But do me a favor, don't check the board until you get it. I get the slope of AB is equal to 3. Now notice I will use subscript everywhere. M sub AB is how I'll keep track of that this is AB. All right, when we switch here, M sub ML, and I'm going to write it as LM so it looks a little bit more clear. Andrew, if I'm trying to find the slope of L and M, what's Y1 and Y2? What do you want me to put in the numerator? Looking at these 2 points right here.
3 and 0.
So 3 minus 0, I'm cool with that. The second I commit to 3 minus 0, I did this. 3 minus 0. Vincent, what has to go in the denominator? So careful. Can you tell me where those came from? Like, here's my y's, and are you okay with why we did 3 minus 0? Y1 minus Y2, that's okay. What's the x side of stuff? In the same order. Minus? Good, so negative 1 minus 0. And here we go, we get a 3 over negative 1 is negative 3. Are these opposites? Are they opposite reciprocals? No. So right off the bat, I can answer 3 things. They're not parallel, I can tell that, because they're not exactly the same. They're not perpendicular, because they're not opposite reciprocals of one another. They're neither of those things. They're just 2 lines that cross. Cool. Feel all right with that one? Ashley, it looks like maybe we have a little bit of confusion.
I thought it was perpendicular.
So, almost. We're so close. Do you agree that this is really over 1? So if we were to flip it, what would it become? And then if you change the sign, it'd be negative 1/3. This is the perpendicular slope. We got negative 3. Is that the same as negative 1/3? Not quite. Like, we're really close. We have the opposite part. We just don't have the reciprocal part. Okay. Should we do another one like that? Yeah, sounds good to me. Should we make it a word problem? Lily says yes. All right, let's get one more. Okay, in your notes, I want you to determine, example, parallel, perpendicular, or neither. Now, you will see me use the subscript like I just referenced. I would encourage you to do it as well, because if we all write the same, it'll be easy to work out what's happening. But let's check it. I have on example A, I have line K. So here's line K with my fancy cursive, and I actually kind of hate it. K. And let's see, K has 2 points on it. K has the point -3, 3 and -1, 4. Just to be really clear, if anybody's still miswriting it and they haven't asked, this is not my plus, this is my and. All right. Beyond that, we know that line N has 2 points on it also. It has the point 1, 0, and it has the point -1, -1. All I want to do is decide if lines K and N are parallel, perpendicular, or neither. Now, for this, I'm going to shove you in the right direction. At least I'm going to make you guys shove me in the right direction. If you want to determine if they're parallel, perpendicular, or not, what do we have to calculate? Guaranteed. The slope. Now, I would encourage you to use the same notation that I do. Slope is m, and if I want the slope of line K, instead of having m equals and m equals and getting lost, I would strongly encourage use that little subscript, m sub k. It's the slope of line K. Similarly, when you get to it, I want you to find me the slope of line N, and I would make sure to use a subscript to really make sure it's clear to see. All the scratch work below, I'm going to give you guys just a moment. Talk it out. I'm going to come around, and if I see it not working, I'm going to sit down and work with you, but I'd rather you ask than make me do that. Do I need to show a ton of work here? Do I care if you show a ton of work? No, realistically. If you can do the mental math, I'm cool with it. With always remember that a quiz, test, mental math doesn't get you points. Okay, so let's see. If we're doing K and I'm using a subscript, smaller and underneath, I'm going to do this order. Just kidding, I'll do red though. Raylene, what's 4 minus 3? 1 over. Carson, what's -1 minus a -3?
+2.
So it's -1 plus 3, -2. I think the slope on K is 1/2. Okay, if you remember, minus a negative turns into a big add, I think is what Jarvis teaches it as, which is so close to being an inappropriate phrase, but maybe that's what it sticks in people's heads with. Okay, let's see. I'm going to start this one. -1 minus 0. -1. Interesting. Over -1 minus 1. Now I have a negative over a negative. Is that redundant? Like, that's more than I need, right? What's a negative divided by a negative? So it's positive 1/2 in the end. Okay, so at this point, we just check. Here's my, I'm going to write it down here because I like it more here. What's the slope of K? And what's the slope of N? Are they the same or opposite reciprocals or neither of those? Therefore, what do we conclude about these lines? So you could just write parallel. I'm fine with that. Being more specific, whether you use therefore or not is entirely up to you. I like it. We just found that line K is parallel to which line? N. Boom. We're done. Okay. We are going to split this section. I'm going to give you guys like the remainder of class, which will shake out to be like 5 to 7 minutes realistically. I was going to give you one big assignment, but I think we could just do it in 2 because tomorrow we're going to be looking at writing equations of lines. So let's see here. I want you guys to do, let me double check. Sorry. I wasn't expecting to split it up. So 1, 2, 3. Okay, so I want you guys to do the following problems, and we'll go ahead and put it on the classroom here. So we're in 3rd hour today, and I will update all the other stuff. That's not even there. 9:30. That was actually yesterday, wasn't it?
Just today. 9:30 is today.
Right, but that was yesterday's, I think. I don't know. I'm all goofed up with that. That's all right. Okay, 9:30. I'll fill in all the other details here in just a moment. I want you to do homework 2.4.1. And you're going to find this waiting for you on page 99. I want you to do, not that one. 18, 20, 21, 23, 25, and 30. I'm going to check this at the start of class tomorrow. I may not always physically collect them, but I will always come around and grade them. During the bell ringer, I'll have a reminder to have this out. We'll check it again. I will collect this assignment tomorrow. Do the assignment tonight. I will collect it tomorrow, guaranteed. Cool, cool.